Okay, I'm going to use this video just to review our hyperbolic trig functions, which we haven't been spending a whole lot of time with lately. So I've got two problems up on the board. The first is an indefinite integral, so that's just going to help us remember our derivative and our antiderivative formulas associated with the hyperbolic trig. And then the second one is a definite integral. I think the trickiest part there is that I'm going to expect you to simplify when you plug in those endpoints. Okay. So I'm going to suggest that you copy down these problems, pause the video and try them out, then tune back in and we'll see how you did. Welcome back. Okay, so if I'm working across, I can see that this is just the derivative of tanh. This is almost the derivative of sech. It's the opposite of the derivative of sech. Remember, with the hyperbolic trigs, there's no negative sign in the derivative formula for the three basic ones, sinh, cosh, and tanh. The other three, the three that I think of as the reciprocal ones, sech, cosech, and cotanh, which are the reciprocals of cosh, sinh, and tanh, respectively, those all have a negative sign in the formula. So this is the opposite of the derivative of sech. This is the one piece that I don't recognize as a derivative. But I do recognize that this simplifies very nicely, because notice that's tanh x times cotanh, by definition, is the reciprocal of tanh x. So this is just 1 in disguise. So we're actually integrating sech squared x plus sech x tanh x plus 1 dx. Whoops, not secant, sech. Okay. So we said sech squared, that was the derivative of tanh. This was the opposite of the derivative of sech. And if I integrate 1, I'm just going to get plus x. And then don't forget, with your indefinite integrals, you're looking for a family of functions, so there's always that plus c. All right. Here, an antiderivative of sinh is cosh. Hyperbolic trig is nice because the derivative of sinh is cosh, the derivative of cosh is sinh. I don't have to think about which one has the negative sign. So I'm going to get cosh of x evaluated between natural log of 3 and natural log of 2. So here's where I need to remember that cosh x was defined to be the average of e to the x and e to the negative x. So it's just e to the x plus e to the negative x divided by 2. So that's going to be e to the ln 3 plus e to the negative ln 3 all over 2 minus what I get when I plug in ln 2, which is e to the ln 2 plus e to the negative ln 2 all over 2. And remember, a negative exponent does not make this negative. E to a power is never negative, okay? So the output of my exponential function is not going to be negative. Here, what I get, the exponential and the log cancel, that gives me 3. A negative exponent tells me I'm taking the reciprocal. So instead of 3, this is 1/3 over 2. And then I'm subtracting. E to the natural log of 2 is just 2. Those inverse functions undo each other. Plus the reciprocal of e to the natural log of 2, which is the reciprocal of 2, all over 2. So now I just want to simplify those two things. So let's see, this would be 9/3. So 9/3 plus 1/3 would be 10/3. Here, let me give myself some more space. I'm just going to come over here. That would be 10/3 divided by 2 is times 1/2. Okay. Minus 2 would be 4/2 plus 1/2 is 5/2 times 1/2. Okay. Now here I can cancel a 2 with the 10, so I'm going to get 5/3 minus 5/4. Looks like we'll want a common denominator of 12. Okay. So that's going to be 20/12 minus 15/12. That is 5/12. Good stuff. I'm just going to put one more up that does involve, again, a definite integral, because for some of you it may have been a little while since you've had to plug into one of these hyperbolic trig functions, and we can probably use a little more practice with that. Okay. So let's just try the integral from 0 to the natural log of 5 of sec squared x dx. So I'm going to end this video here, give that one a shot. Again, at the beginning of the next video, I'll just give you the answer so that if you feel confident that you did it right and you've got the right answer, you don't need to watch the video unless you want to. You're certainly welcome to. But if you want to move on to the next one, you can. But if you feel at all shaky on this, then you can watch it and we can work through it together.